In this video, we're going to be covering stationary points on a curve. Now remember, the sign of the first derivative can help us determine what the gradient is. So if the first derivative is greater than 0, it means the curve is increasing. If the first derivative is less than 0, it means that the curve is decreasing. Now, if this first derivative equals 0, we know we have a stationary point there. Now, two types of stationary points we have are a minimum and a maximum turning point. So at a minimum turning point, the curve is decreasing, as you can see on the left-hand side there in the blue, and then hits your 0, then begins to increase on the right-hand side, as you can see in the green. We also have a maximum turning point where the curve is increasing on the left-hand side in the blue, hits your 0, and then decreases on the right-hand side, which you can see in the green. So we do have two types of these. We have a global and a local. So a local maximum or minimum are relatively high or low points. They're not necessarily the highest or the lowest, but they're relatively high or low points for a function. Now a global maximum or minimum is the highest or lowest value of the function in the set domain given, so over the certain values of x's. Now we also have something called horizontal points of inflection. Now these points are increasing or decreasing, but on both sides of the point. So on the left-hand side there, you can see we're increasing in the blue, we hit 0, and then we start to increase again in the green. Whereas on the right-hand side, you can see we're decreasing in the blue first, we hit our 0, and then we begin to decrease again. So this isn't a turning point because the curve does not turn around. So we're going to look at our first question here, and it says find the turning point of the curve y equals 3x squared plus 6x plus 1 and determine its nature. So when it means determine its nature, it just means we need to determine what kind of stationary point it is, whether that means it's a maximum, minimum, or inflection point. Alright, so the first thing I always like to do is rewrite my function. Now with these type of questions, the second thing you want to do is find the first derivative. So this becomes 6x and this becomes 6. Okay. Now that we've done that, remember for a stationary point, that first derivative is equal to 0, and that's what we're trying to find. So what we do now is we assume that this equals 0, so 6x plus 6, and then we can start to do our rearranging. So minus 6 minus 6, we get minus 6 equals 6x, and then we can divide, let me cross that, divide by 6, and we get x equals negative 1. Now that we know that, we should probably find our y value, because this is a set of coordinates, so you need an x and a y. So we can say let x equal negative 1. So we go back to the original function, and we're assuming our x's are negative 1 now. So again, when I say we go back, we're going back to this up here, and we're changing all the x's to negative 1. So we get 3 times negative 1 squared plus 6 times negative 1 plus 1. Now if you put that straight into your calculator, you get an answer of negative 2. So we know that the coordinates of our stationary point are going to be at negative 1, negative 2. So now that we know that, we need to determine its nature. So I like to create like a little table here to determine its nature, where I have my x, I've got my first derivative, and then down here I've got gradient. Oh. Alright, so imagine this is like your little table going across here. So what I'm saying is, I know I've got a point at negative 1, so I'm going to put my negative 1 there, but I want to know what's happening to the left and the right. So what I'm going to do is I'm going to pick the number to the left, which can be negative 2, and then I'm going to pick a number to the right, which is 0. I then go back and find these derivatives, all right, the first derivative of these. So what I mean by that is, when I go back up here to my y here, y equals 6x plus 6, what I'm doing is I'm changing these to negative 2 and to 0 to find what that is. All right, so again, what I mean by that is, here, if I go negative 2 equals 6 times negative 2 plus 6, put that in a calculator and you end up with negative 6. All right, so again, I'm not going to do that every time, but it is how I'm doing it. So this becomes -6 here. So let's get rid of this. And you do the same for, we know this is already 0, we've already found it. We do the same for 0 now, and that comes out as 12. So in this next step where I say I've got gradient, I'm saying, well, what type of gradient is it? Is it positive or negative? So here we have negative, and here we have positive. Now, because we're going from a negative to a positive, this is a minimum turning point, all right? Because we're going down and then up. We're going from negatives into positives, all right? So we've just done that question. So the next one, here's another one. We have two stationary curves this time, and we need to find them. So you start the same way. X cubed minus 3x plus 2. Find your first derivative. Let it equal 0. So 0 equals 3x squared minus 3. I noticed that there's common values here. So what I'm going to do is factorize this. So we get 0 equals, so I'll write it HCF equals 3. So we get 3x squared minus 1. I can then divide by 3. And since 0 divided by 3 is still 0, I'm left with 0 equals x squared minus 1. And you'll notice that both of those are square numbers. So that means this is the difference of two squares. So we get 0 equals x plus 1. X minus 1. Now remember, when you got difference of two squares, you just square root both of them and put them in the brackets. So x squared square root is x, and 1, the square root of 1 is 1. And then you just have a plus and a minus on both sides. So this means that my x's can be -1 for the first bracketed area and then +1 for the second. So we have two stationary points here. So let's focus on our x equals 1 first, because positives are just easier to deal with. So what I do there is I find my y value. So I substitute it back into the original equation function up here. That equals 0. So we know our stationary point is at 1, 0, and then we do that table again to determine its nature. We've got x, we've got y, the first derivative, and we've got gradient. So if we're saying x is 1, I can pick 0, 1, 2. Again, I'm not going to do this, but remember, we're just substituting these values back up into this formula here to get the values. So when it's 0, that becomes -3. We know this one's 0, and this is 9. So we're going from negative to positive. So this is negative to positive equals minimum. So if we do the next one, we're saying let x equal -1 this time. Now I'm not going to go through and do the exact same thing I did, so I'm going to quickly just get the answers up. So when I substituted -1 in, my y value became 4, so I know I have a point at -1, 4. I then do my table, x so we have -2, 0, -1. Oh, sorry, -1, 0. What am I doing? -1, 0, like that. We get 9, 0, -3. Remember, you just substituting it into that first derivative. So we go from plus to minus, and positive to negative is a maximum. All right, so we've just done our points and found their nature. So to recap the video, remember the sign of the first derivative helps you determine the type of gradient it is. So if it's greater than 0, you know you have a curve that's increasing. If it's less than 0, it's decreasing. And the most important one is when it is 0, that is a stationary point, because that's the starting point for all these type of questions. Now, remember you have two types of turning points. You have a minimum and a maximum. A minimum has a curve that's going from negative to positive, and then the maximum has a positive going to negative. Now remember you have locals and globals. Locals are just any kind of max or min on the curve. It's a relatively high or low point, whereas a global is the highest point or the lowest point. Now we didn't see any horizontal points of inflection. We'll cover that later, but it's important to know these are found by also finding the first derivative equals 0. So this is when your curve is increasing and then increasing again, or decreasing, then decreasing again.